Hello everyone, very good evening to all. In the first class of moment of inertia, we have discussed theorem of up to the theorem of perpendicular axis. And in the first class, I have explained what is moment of inertia, and we have derived a relation or equation for moment of inertia of a rectangular section with respect to its centroidal axis. And I have mentioned what is centroidal axis. An axis kept at the centroid is called the centroidal axis. So while coming to normal problems, we have to calculate the moment of inertia with respect to some other axis which is away from the centroidal axis. So in such cases, we have to use another theorem that is called parallel axis theorem. According to that theorem, the moment of inertia of the section is given with respect to any other axis which is away from the centroidal axis is given by the equation IAB equal to Ig. Ig is the moment of inertia. We have some, for rectangle we have equation BdQ by 12. So it will be BdQ by 12 plus AH bar square. A is the area of the cross section for rectangle. L into B or B into D is the area of cross section into H square. H is the distance between the center of gravity of the section and the axis AB. And you have to study the statement. If the moment of inertia of a plane area about an axis through the center of gravity is denoted by Ig, then the moment of inertia of the area about any other axis parallel to the first and at a distance h from the center of gravity is given by Ig plus h bar square, h square or h bar square. And you have to study the proof for that. Normally, this is a circle. We are calculating the moment of inertia with respect to the centroidal axis. Now, this case I have to calculate the moment of inertia with respect to an axis AB, which is at a distance h from the centroid. So, in the first class I have explained moment of inertia can be written as A into distance square. So, A into distance equal to h plus y. Ig is equal to IAB sigma A into h plus y all square gives the moment of inertia. I am expanding the h plus y all square sigma A into square plus y square to hy, and expanding the bracket sigma x square dA, sigma y square dA, sigma 2 hy dA. Sigma y square dA we have already know that it's a Ig. Sigma x square dA can be written as x square into A. dA will become area of the cross section, and sigma 2 hy dA can be taken as 0. And there is some reason for that, and no need to write it. Okay, so if we calculate the moment of inertia with respect to any other axis which is at a distance h from the central axis, the moment of inertia is given by Ig plus AH square. Okay. And in addition to rectangular, we have to study two more sections for solving the problem. The first one is triangle and the second one is circle. And you need not study the derivation and all. You just see that. Just study this equation ph cube by 36. This is the equation for moment of inertia of a triangular section about an axis passing through the center of gravity or centroid. Value of x-axis is equal to bh cube by 36. Okay. If the moment of inertia with respect to base is bh cube by 12, no need to study. Just study what is the moment of inertia with respect to centroidal axis bh cube by 36. For rectangle we have already studied that it is bd cube by 12. For triangle now it is bh cube by 36. And we have to study one more section, that is the circle, and its equation is pi by 64 d raised to 4, that is ixx plus iyy. In the first class we have studied perpendicular axis theorem. Ixz is given by ixx plus iyy. So ixx equal to iyy is equal to pi by 64 d raised to 4. Then Izz will be 2 into pi by 64 d raised to 4 or pi by 32 d raised to 4. Again, you need not study the equation. You just study what is the value of ixx and iyy, pi by 64 d raised to 4. And this is already we have studied in the perpendicular axis theorem. And moment of inertia of a hollow circular section. We have to First we have to calculate the moment of inertia of the larger circular section, then we have to calculate the moment of inertia smaller circular section, and we have to subtract the second one from the first one. Pi by 64, the outer raised to 4 minus the inner raised to 4 gives the moment of inertia of a hollow section. Okay. And if the circle is, if we are taking the semicircle, the initial equation is 5 by 64 d raised to 4. Its half will be the moment of inertia of the semicircle about the base, because I am telling base is we have taken the axis at AC, which is already at the center. While we are taking the semicircle, it will be the base of the semicircle. So we have derived the equation pi by 64 d raised to 4 with respect to the axis AC. So when we are taking the semicircle, the axis AC remains here. So with respect to axis AC, it is 1 by 2 into pi by 64 d raised to 4. If we are taking about the centroid, it will become, again we have to use the equation. Again, you need not to study this equation, you just know how it is calculated. So about base is about centroid plus h square. So about centroid equal to about base minus h square, which gives the moment of inertia with respect to centroid. We did not study this equation. We just study this equation about the base 1 by 2 into pi by 64 d raised to 4. Now we will discuss two small problems. You see the figure, it's a L-type cross-section, and we have to calculate the moment of inertia with respect to an axis KK. It's marked here with respect to an axis KK. L-type cross-section we have studied, but we can cut the L-type into two pieces. So it will become two rectangles, and we can calculate the moment of inertia with respect to an axis at a distance 100 from the base. So we have to use the parallel axis theorem. I xx equal to, or I by y is equal to b dq by 12 plus a h square. So in this case, kk can be taken as a y-axis. So we will be calculating I yy because it is perpendicular to the plane. If the kk is drawn here, it will be taken as a x-axis. So you just write ikk. Okay. First step, I will be dividing the L section into two pieces. First one is having a width of 40 mm and having a height of 120 mm. And the second one is having a width of 240 mm and having a height of 40 mm. So first section I will be calculating I can be written as IGG plus AH square. So I will be writing IG1 plus A1 H1 square. So IG, the section is a rectangular section. It will be breadth into depth cube. The side which is parallel to the axis can be taken as breadth. The side which is perpendicular to the axis can be taken as breadth. So breadth is equal to 120 into depth. So 40 cube will give us the IG1. 120 into 40 cube divided by 12 will give us the IG1. And H is the distance from the axis to the center of the section. So from the K up to the starting of the section, we have to 100 mm, and the total width of the section is 40 mm. So up to the centroid it will be 120 mm. 100 plus 40 by 2 will give us the 120 mm. So IG we have calculated, H we have calculated. A you can directly calculate it, 40 into 120. So 640 raised to 3 IG plus 120 to 40 gives the area of section, and H is equal to 120. The moment of inertia of the first section. Then moment of inertia of the second section. IG2, again breadth into depth cube. So this is the axis, the side which is parallel to this axis. For second section, the side parallel is 40 mm is parallel to the axis. It will be the breadth, and a 1 to 40 mm is perpendicular to the axis, which is taken as depth. So breadth into depth cube. So 40 into 240 cube will give the moment of inertia of this section. 40 into 240 cube by 12 which gives the moment of inertia of this section. And H2 is the distance from the axis to the center of the section. Up to the starting of section 100, total length of section 240, its middle will be 120. 100 plus 120, 220 will be the value of H2. So Ig2, solid calculator 46.086 millimeter raised to 4 plus A2, 240 into 40 into H2 equal to 220 square will be the moment of inertia of the second section. So we got two moment of inertia, 69.76 10 raised to 6 millimeter raised to 4, and second moment of inertia 510.72 into 10 raised to 6 millimeter raised to 4. So total moment of inertia of the section will be given by the sum of these two. So value is 580.48 into 10 raised to 6 and its unit is millimeter raised to 4. So I think you got the idea. Okay, we'll discuss one more problem. The second one is find the moment of inertia of the T section. You can see the T section having width 150 and depth 150 and having a thickness of the flanges 50 mm. In the first question we have given the axis. For the second section, about x-axis and y-y axis through the center of gravity of the section. We have to calculate the moment of inertia of the section with respect to first axis is x-axis axis, and they have mentioned the position of the x-axis as at the centroid. So we don't know the centroid of the given section. First you have to calculate the centroid of the section and then you have to draw the axis of the given section. Let's calculate the moment of inertia of the section about the x-axis and y-y axis passing through the center of gravity of the section. So first you calculate the center of gravity of the section, then mark the axis and then go for the calculation of moment of inertia. First step is the calculation of center of gravity. So already now y bar and x bar we have to calculate. Then you can locate the center of gravity. As we can vertically cut the section into two pieces, so its geometrical center will lies in this vertical line. So now need to calculate the value of x bar. So we have to calculate the value of y bar, ay1 y1 plus a2 y2 a1 plus a2. By cutting into two sections, we will get this 125. So from the base it will be at a height of 125, which is the, here is the total height is 150 mm, up to here will be the axis. This is the vertical and horizontal axis. Now we are going to calculate the moment of inertia about the x-axis. So I will discuss the detail in the next class. Hope you got an idea how to calculate the moment of inertia with respect to an axis at a distance x from the center of gravity. Now in the next problem we will be discussing how we will calculate the moment of inertia with respect to centroidal axis. So these are the two types of questions that will be asking in the unit examination. This is a simple cross section constitution, only two rectangles, L-shaped section. But for the unit examination you will get circle, semicircle, hollow circle, hollow cylinder, hollow rectangle, or some complicated section you will get. So please you prepare notes and be ready. I will give you homeworks, you have to complete that. And if you have any doubts and suggestions, you can communicate through personal message, through WhatsApp or email. Hope you are easily following my lectures. Your suggestions are always welcome. So thank you. Good night.